Hello, welcome to xenocyphers.org. My name is Cortelia Kataria and I am a 9-year-old computing explorer and problem solver. I got a 9 on my GCSEs and right now I'm doing my A-levels. Hello, test.
And what we've done here?
We're going to do A-level mathematics session.
So I'm Isaac. I'm an experienced maths teacher here to help with the Deciphers.org, providing sort of my experience to help you revise for your A-level maths and help Cortelia along the way when he's answering these questions. So we are carrying on with the paper that we've been working on over the last few sessions, which is October 2021, paper 1 from the Edexcel series.
I guess Mark also joined. Hello, Mark. So question 10.
So as we're going through these questions, remember that if you have any of your own questions or if you have a different way to solve it that you'd like to share, then please just feel free to put it in the chat and we'll answer your questions in there. And we're open to discuss your methods as well, which is sort of the whole point of this peer-to-peer platform for learning and problem solving.
Yeah. So, question 10. Given that 1 plus cos 2 theta plus sine 2 theta is not 0, prove that 1 minus cos 2 theta plus sine 2 theta divided by 1 plus cos 2 theta plus sine 2 theta is tan theta. And that's part A, and part B is, hence solve for 0 is less than x is less than 180. And 1 minus cos 4x plus sine 4x divided by 1 plus cos 4x plus sine 4x, and that's 3 sine 2x. And giving your answers to one decimal place where appropriate.
Good. So it's part A. What's probably a good thing to do to start, Cortelia?
Maybe multiply out by 1 plus cos 2 theta plus sine 2 theta.
Okay. The issue with that though is that it's an identity that we have to prove. So we need to, whenever we're proving an identity, we need to start with either the left hand or the right side and manipulate it until we get the other side. If we multiply through, we're treating it like an equation, which is not always mathematically correct. So because we're asking to prove this identity, we need to think about what other identities we might be able to use in our manipulation. And maybe write some of these down that will help us solve this. So looking at that question, what identities do you think we might need?
Cos 2 theta. We could use cos 2 theta if I'm not sure which one to do.
There's different forms, isn't there? Maybe write them all down.
Yep. So is so there was I forgot which one. I forgot which one they were. I think that was there was 1 minus 2 sine of.
Yeah, that's exactly right. So you're not given the double angle formulae in your exam book, but you are given the compound angle formulae. So I'm going to just write that down by the question so we can see how we could use that to, if we forgot the double angle formula, how we can quickly think about how we'd use that to get the double angle formula. Okay, so that's the formula that we're given in the exam, but cos A plus or minus B is cos A cos B minus plus sin A sin B. So you didn't need to get rid of what you wrote, it was perfect, you were right. But think about how we could use that to get our double angle formula for cos.
So we could use cos of 2 theta is the same as cos of theta plus theta, which is cos theta and then squared because it's cos theta times cos theta.
Brilliant.
Minus sine squared of theta.
Good.
So we know that cos squared is 1 minus sine squared. So that's 1 minus sine squared of theta minus sine squared of theta. So that's 1 minus 2 sine squared theta.
Yeah. So we've got 1 minus 2 sine squared theta. And there is another form as well, which we might not use, but let's write it down anyway. Do you remember what it is?
And so 2 cos squared minus 1 is 2 cos squared of theta minus 1. Because if we look at this equation, then sine squared is also 1 minus cos squared, so
yeah, so we end up with cos squared minus 1 minus cos squared, which is 2 cos squared minus the 1. Yeah, good. Okay, and what about for sine 2 theta? Again, I'll write down the compound angle formula for sine that we can then use to get the double angle formula. So again, that's one that's given to you in the formula book. You need to remember it, but you're not given the double angle formula, so you have to think about how you'd use that to get the double angle formula. A good way just to refresh your memory.
okay. So sine of 2 theta, that's sine of theta plus theta, which is, so sine of theta times cos theta plus sine theta cos theta is 2 sine theta cos theta.
Good stuff.
So,
Okay, so now we'll remember the double angle formula. Let's think about how we could use that to help us start with our identity.
we could just sub in the double angle formula for cos 2 theta and sine 2 theta into the equation, and then we need to make them cancel out somehow to make sine theta in cos theta, which is tan theta.
Yeah, good. So let me write down, so from our start, a good step is always write down the left hand side. So I'm just going to write that down for you to work off of, so you don't have to keep scrolling back up to the question as well. Okay.
We can use So that was the equation. We can use 2 cos squared theta minus 1.
I think
1 minus 2 sine squared theta.
Yeah, so remember you said the target should be to end up with sine theta over cos theta, so a good idea would be to try and get sine thetas on the top. So I think you're right to use this form of the cos 2 theta 1 minus 2 sine squared theta.
Yeah. So 1 minus 2 sine squared theta is 1 plus 2 sine squared theta minus 1, then plus 2 sine theta cos theta.
Good.
And then the plus 1 and minus 1 cancel out.
Well, let's do the denominator first, maybe.
Yep. So it's divided by 1 plus and then we want causes on the bottom. So
So I think we will want causes on the bottom, but it's a tricky one. When you've done lots of these questions, you'll see little tricks and stuff, and you'll be sort of already thinking about what you're going to see. And you're right that those ones are going to cancel out on the top. You said that. So think about the fact that you're going to have something with just signs in it at the end, aren't you, that you're going to be able to factorise out. So actually it might be best to change it to use that same double angle formula again, the 1 minus 2 sine squared theta.
yeah, so 1 plus 1 minus 2 sine squared of theta and then plus and then sine 2 theta, that's 2 sine theta cos theta.
Mm-hmm. Now remember, with an identity, it's really important that we actually show each step of our working out, so don't try and do too much in one go. So let's just simplify that. Let's select the right term, simplify what needs to be simplified before we start making any other substitutions or cancellations or anything.
Yeah. So that's the same as 2 sine squared theta plus 2 sine theta cos theta divided by 2 minus 2 sine squared theta and plus 2 sine theta cos theta.
Good stuff, yeah. Let's look at the numerator first. What do you think you might be able to do to the numerator? Maybe just go on to the next page.
Yeah. So the numerator, and we can factor out 2 sine theta, make times sine theta to make 2 sine theta times sine theta
Good.
plus cos theta.
Excellent. Okay. And then the denominator is a little bit trickier because obviously we've got that 2 still in there, so we can't factorise anything out just yet. But we can look at our numerator and think about what we're trying to get. You said before we're trying to get sine over cos. So we can see that we've got the 2's that are going to cancel out, which is nice. And we've got the sine theta times this something. So if we can get that something, the sine theta plus cos theta, on the denominator as well, then when they cancel out, we'll be left with hopefully a cos theta to make sine theta over cos theta be tan theta. So what do you think we might need to do to get to that step?
I think that we might need to that's just we can factorize that out, because that looks pretty similar to sine theta plus cos theta squared, because except it's only sine theta cos theta, not 2 sine theta cos theta.
Okay.
I'm not sure.
So remember, we're going to want this denominator to probably be 2 cos theta times by sine theta plus cos theta, aren't we?
Yeah.
That's probably what the target's going to be, because we want the 2's to cancel out, we want the brackets to cancel out, and we want to be left with sine theta over cos theta, don't we? Yeah, so you can see that with what we're going to do is be factorising out 2 cos theta.
Yeah.
But we have the 2 cos theta here, but we don't have 2 cos theta here. We've got the 2, so is there something we can do? So 2 minus 2 sine squared theta. Does that look familiar at all?
It looks the same as 2 cos squared theta, because
Brilliant.
Because that's 2 times 1 minus sine squared theta, and that's 2 cos squared theta.
Yeah, so I'm going to just write that down. 2 minus 2 sine squared theta is 1 minus sine squared theta, which you just told me is 2 cos squared theta. Okay, so we can do that for our denominator.
Yep. So let's divide by 2 cos squared theta plus 2 sine theta cos theta. And that's 2 sine theta times sine theta plus cos theta divided by 2 cos of theta.
Yeah, so what are we doing to the denominator?
The denominator, we're just factorizing 2 cos theta.
Brilliant.
Times cos theta plus sine theta.
Fantastic.
And then these 2 cancel out, and the 2's cancel out.
Excellent.
And that's equal to sine theta in cos theta, which is the same as tan theta.
Fantastic. Okay, so yeah, and you finish your proof, therefore it's the same as tan theta, yeah?
Yeah.
Okay, I'm just writing down part B so you don't need to keep scrolling up on the page below. So we've got 1 minus cos 4x plus sine 4x over 1 plus cos 4x plus sine 4x is equal to 3 sine 2x. Okay, and we want to solve between 0 and 180, given our answers to 1 decimal place.
So we showed that 1 minus cos 2x plus, show that 1 minus cos 2x plus sine 2x divided by 1 plus cos 2x plus sine 2x, and that we show that that was tan theta.
Yeah, remember don't mix up your thetas and x's because you've got x's on the left but thetas on the right.
Tan x. And then if it's 4x, then let's just do y equals, if y equals 2x, then we just use the same expression with y.
Yeah.
So instead of x, it will be...
Well, you could do theta, couldn't you? Because the original bit was theta rather than y. The original question was theta.
So
so if you do the substitution, theta equals 2x.
Then we get, then that's the same as tan off is tan 2x. So we want to find all solutions to tan 2x is 3 sine 2x.
Brilliant.
Sine of 2x divided by cos 2x equals 3 sine 2x.
Good.
Okay. So if we divide by sine of 2x divided by 3, then we get 3 in cos 2x is and that is
Would it not be 1 over 3 cos 2x?
yeah, 1 over
Rather than 3 over cos 2x? I can see what you're doing there, Corsair, but I don't quite like it. Because the problem is that when you divide through by sine 2x, you do what's quite a common mistake. And you can do it as long as you realise the mistake that you might make, is that there's something in maths that you can't do, or that you can't divide by, and what's that?
You can't divide by 0. So
Yeah, and sine 2x might be 0. So if you're doing it this way, you'd have to recognise that sine 2x equals 0 would be a solution, because that's you can see that if sine 2x is 0, both sides equal 0 and the equation holds true. So I would say rather than dividing by sine 2x, because if you do, then you might forget that extra step where you set sine 2x equals 0 and you might miss some solutions. So I'd say let's not do this way, so can we get rid of that last bit of working out, and rather than doing that, let's times through by cos 2x. Because then we're definitely not going to miss any solutions out by division.
So if we times by cot 2x, that's cos 2x divided by sine 2x. And then for this side, it just cancel out to make 1. And then for this part, 3 sine 2x times cos 2x divided by sine 2x.
Again, you're dividing by sine 2x. So you're going to get, so if you recognise that sine 2x equals 0 is a solution, that's fine, but there's just, I think, a more efficient, a better way of doing it, and that's by just timesing by cos 2x. Yeah? And we're going to use some factorising rather than division.
Okay. So if we times by cos 2x, that's sine 2x equals to 3 sine 2x times cos 2x.
Good.
Sine of 2x times by 1 is...
Can we make it equal 0?
Yeah, that's what I'm going to do.
Yeah.
Minus 3 sine 2x cos 2x. And that's 0. Just about finished. And that's sine 2x times by 1 minus 3 cos 2x.
Good.
And that equals 0. So sine 2x is 0, and then that's, if sine 2x is 0, then let's do on the next page. So if sine 2x is 0, then 2x is and also we want to do that from ranges 0 less than 2x. 2x is less than 360.
Good, yeah. So we've solved for x, but first we need to solve for 2x, so we need to consider the range for 2x, which, yeah, smart and good step. A lot of people forget that. That's could be how many smarts, but yeah, change the range of values for which we solve for. So yeah, well done.
It's 0. Wait, no, it's not 0 because it was less than. So solutions of that is 0, 180 and 360.
Brilliant.
180 is the only one in the range. So x is 19 degrees and degrees.
Good, well done. So that would be the solution that we would have missed out if we forgot that sine 2x could be 0. If you divided by sine 2x, we would have missed that solution out.
Yeah. So, and the solution 1 minus 3 cos x equals 0. So 1 is 3 cos x. Cos x equals 1 and 3. X is
Yeah, we need our calculator for this one. Remember it's 2x, not x.
I am 2x is, and it's from 0 to 360 again.
Yeah.
So the first solution is 70.53.
Excellent.
And the second one is so the second solution for cos is 360 minus that.
Brilliant.
And it's 289.47. And so x is for the first one, that's 35.226, and for the second one, it's 144.74.
Fantastic.
Time for question
Okay.
11.
Yeah, question 11. So it looks like an integration question. So figure 2 shows a sketch of part of the curve with equation y equals ln x all squared, x is greater than 0. The finite region R, shown shaded in figure 2, is bounded by the curve, the line with equation x equals 2, the x-axis, and the line with equation x equals 4. The table shows corresponding values of x and y with the values of y given to 4 decimal places. Use the trapezium rule with all the values of y in the table to obtain an estimate for the area of R, giving your answer to 3 significant figures.
Okay, so for part A, so for the trapezium rule, just split it into trapeziums.
Yeah.
And then let's
There is the formula. Do you remember? Maybe write down the formula if you remember it. It is one given in the formula book.
I only remember the formula for the area for trapezium, not
Okay.
the trapezium rule.
So I'll write it down for you. So the area, so it basically is the area of the trapezium, but adding lots of trapeziums together. So you have h over 2, just like a trapezium, the height over 2, and you have the two end values together, so let's call that y0 and yn. But because we've got these end strips of that are trapeziums, the end values will only be used once because they're in only one trapezium, but the other lines will be used twice. So they're going to be plus 2 lots of all the other, they're called ordinates because they're just one part coordinates. So y1 plus y2 plus ... plus yn minus 1. Okay, so that's our formula for the trapezium rule. Do you know what h would be in this case?
H is just 4 minus 2, which is 2.
It's not just that, because it's what the trapezium rule is doing. It's splitting it up into these strips of what we've got. So splitting it up into 4 strips. So H is the width of one of those strips. So it's going to be the difference between these two.
So it's going to be 0.5.
The 0.5, yeah.
So a quarter, that's the same as a quarter times 0.4805 plus 1.9218 plus 2 times all of this plus that, and then dot dot dot.
So H over 2 times the two end values, so 2.4805 and 1.9218 plus 2 lots of the middle ordinates. Yeah, well done.
I'm just working it out in my calculator. 0.9218 2 times it's 0.8396 plus 1.2069 plus 1.5694. That's about 2.41.
Brilliant, yeah, three significant figures, 2.41, fantastic.
Part B.
So part B, use algebraic integration to find the exact area of R. So remember, trapezium rule just gives an approximation. Use algebraic integration to find the exact area of R, giving your answer in the form y equals a ln 2 squared plus b ln 2 plus c. I don't know why it says that's got to be an error in the question for the area to be given in the form y equals.
Yeah.
It's not going to be y equals, is it?
Yeah.
Where a, b and c are integers to be found. So tricky integration of ln x all squared.
Yeah. ln squared of. So now we want to find the integral from 2 to 4.
Brilliant.
That is integral of 2 to 4 of ln of x times ln x is I think we can use the reverse chain rule. Or what's an integration by parts? I forgot which one.
Yeah, it'd be hard to use the reverse chain rule in this case. So let's use by parts. I'm just going to write down the formula for by parts just so, again, it's one that's given to us, but I'll write it down so we can refer to it throughout. So the integral of u dv dx is equal to uv minus the integral of v du dx.
Yeah. So it's just Liddy, and it's left integrate derivative integrate or something like that. So ln x times ln x minus integral of minus integral of ln x, then integral of ln x is just 1 in x.
The derivative of ln x is 1 in x. So tell me what you've done, able to do to get the ln squared x.
So what I did was uv, that's ln x times ln x. Wait. Oh yeah, we need to.
So I think it's going to be...
Because it's, we have to integrate v because it's u times dv and dx.
Yeah, so... Yeah, remember, I think it will help if we write down what u is and what we're setting as u and what we're setting as dv dx. And there's two different ways of doing it. There's the way that you're going about it, saying that they're both ln x. Yeah, you're splitting the ln squared x into ln x and ln x. And that's okay if you know the integral for ln x, which you may do. If you don't, then you've got to use by parts to get it anyway. So there's a slightly easier way of doing it, where we set u to be ln x all squared and dv dx to just be 1. Because we can differentiate ln x all squared, I would say easier when we could integrate ln x.
Okay, so...
Do you know the integral for ln x, just out of interest?
No.
No. Yeah, so let's go with setting u to be ln x all squared, so make sure we write it down so we can see it as well. So u equals ln x all squared and dv dx equals 1, and then we can show what du dx is and what v is.
Rewrite that part. 2x times 1, which is this is so the integral of u dv by dx is...
Okay, so I'm just going to write down u equals ln x all squared, dv dx equals 1. So I want you to write down for me du dx and v.
ln squared x times and the integral of 1, which is just x.
Good.
Minus 1 times the du by dx, 1 times the derivative of minus the derivative of ln squared x. That's using the reverse chain rule. That's just 2 times 2 is ln 2 times ln x times wait a second.
Yeah.
And then multiplied by the derivative.
Good. And the derivative of ln x is?
1 in x.
Good. Okay. You said the reverse chain rule, you meant the chain rule.
the same
Okay.
as x ln squared x ln squared x.
Yeah. Remember, it's the integral of that, isn't it?
Integral of what?
The integral of the 2 ln x 1 over x. And I think you've missed a bit out as well, because your 2 ln x 1 over x, that's just du dx, but you need to times it by v.
So, it's by v. So dv dx is 1.
Yeah.
So v is so if du dx is 1, then that means that v is x.
You'd already worked that out for the previous bit as well, hadn't you? Yeah.
So
The uv bit.
yeah, and the integral of v is x squared into 2 times x squared into.
Well, where does x squared into 2 come from?
The integral of v part.
No, let's break it down a little bit. So your uv is this bit, your ln squared x times x, that's right. And then, so you should have your uv is ln squared x times x. Yeah? Or ln x all squared, I should say, shouldn't I? Ln x all squared times x. Okay, and you're taking away the integral of v du dx, so your v is x, du dx you've worked out to be 2 ln x times 1 over x dx. Okay, I think you're trying to do too much, because you're integrating twice in one go, which is causing a bit of confusion. Okay. Actually, let's leave it as an improper integral for now. Let's come back to the bounds.
That is the ln squared of x, that's x ln squared x minus, then yes, so x and 1 over x, they cancel out to make the integral of 2 ln x.
Okay, so now we've got to integrate 2 ln x. Okay, and how are we going to do that?
We can use, you could do parts again.
By parts, yeah. So again, what are we going to set as u?
U is ln x.
Ln x. What are we going to set as dv dx?
So dv dx is 2x. I mean just 2.
Just 2, good. And then I want you to differentiate u and integrate dv dx.
Okay, so that's the derivative of ln x is just 1 in x.
Good.
And the integral of 2 is just 2x.
Good.
Okay. So, UV. So UV, and then that minus the integral of v du and dx
Yep.
of 2x times 1 in x, which is the integral of 2.
Good. dx, don't forget dx again.
2 dx. That's 2x ln x minus 2x.
Excellent. Okay, so we've done all the integration now. So we've got the area equals x, don't forget the first little bit that we did, so x ln x all squared minus 2x ln x plus our 2x. Because remember, we're going to be taking away this bit, so we've got minus 2x ln x, take away negative 2x, so that's why that becomes plus. And remember, we're doing the balance between 4 and 2.
Okay, so if we sub it in at 4, we get.
So remember, it's asking for it in terms of in a particular form, so we're not going to be using our calculator for this bit.
So if we sub in 4, then we get 4 by ln x squared minus 8 ln.
4 by ln 4 squared, remember x is 4.
Minus 8 ln 4 plus 8 that minus 2 ln 2 squared minus 4 ln 2 plus and then 4. So we know that ln of, so we know that ln 4 is ln 4 is ln of 2 squared.
Good.
And then that's the same as 2 ln 2.
Brilliant, so we can make everything in terms of ln 2.
Yep, so that's 2 squared is 4 and 4 times 4 is 16. So 16 ln 2 squared minus 2 ln 2 squared. Then 8 ln 4, that's 16 ln 2.
Good.
Minus 16 ln 2. And 4 ln 2. Then and plus 8 and plus 4 stay the same, and that's 14 ln 2 squared
Be careful with your negatives here.
Minus.
I would probably say that might be a good idea to put brackets around this bit.
Yeah. So minus 12 ln minus 12 ln 2 and plus 4.
Yeah, fantastic. Cool. So that's exactly what we're done.
So A is 14, B is 12, and C is 4.
Good luck. That was a tough question, and for 5 marks, that was a lot for 5 marks.
Yeah,
Particularly when you compare it to part A, that was worth 3 marks, and that was just shoving numbers into a formula. But part B had to use integration by parts twice, and then some tricky logs simplifying as well. It was a tough question, but you did really well done.
I'm just gonna see what the exact value of it is, so we can see how to compare.
So you can compare it to our answer to part A. Yeah, good idea.
So it's 2.41 about, and for part A we got.
You got 2.41.
Yeah.
So the trapezium rule was a good approximation. Well done.
Yeah. And for some questions, they do have a part C which asks you to just do exactly what we did.
Yeah, or work out like the percentage error or something like that, don't they? With your approximation.
Yeah. So we've got about. I think we should stop now because it's been an hour exactly.
Okay, we'll go through 2 questions today, but
Yeah.
hopefully you found it useful.
And especially that our second question was pretty hard.
It was. But we'll keep working through this paper over the next couple of videos. Hopefully we'll get, what are there, 3 questions left, is there? 4 questions left. Hopefully you get it done. One of them's only worth 3 marks. So, yeah, we should be able to get them done in the next video.
And thanks for watching.
Thank you for watching. See you next time.